So you're probably comfortable writing React components using JSX. Now you're looking to enhance your components with statefulness and interactivity. Well, you need to start using React hooks. Welcome to my channel. I'm your personal guide to full stack development. Today we are going to learn the most commonly used React hooks. Writing React hooks can be very daunting at the beginning, but once you learn them and practice writing them, you'll feel more comfortable using them in your components. Now, before we begin, I want you to find that subscribe button and smash that subscribe button. Just smash it. It's for free. It'll help me do more of these content. Come on, do that. useState is by far the most commonly used hook. You can use useState to create stateful variables inside your component. Imagine you have a component called user. You have a variable called first name that has a value Bob. Now you decided to mutate that variable using some browser events or some user interaction. Or you decided to mutate it right after declaring it. Let's say you change the variable to Tom. Now, if you ask React to render this first name in the component, it'll only know the value of Tom because that was the latest value of the variable first name. So in order to tell React that the first name is a state that will change over time on demand, you need to use useState. So useState will give you back an array, most commonly referred as tuple, with exactly two values. The first item in the array is the variable that is going to hold the state. The second item in the array is a setter function which you can use to update the state. Now, in React world, it doesn't make sense to update a state right after declaring it. You might want to update the state in some events on demand. It can be a user interaction, for instance, an onChange event on an input field. By calling the setter function of the useState, you're telling React to re-render the component because some piece of state is changed. So React will re-render the component with the new state. So now you have a state variable with useState. Let's say you want to react to side effects to that state. That is, whenever the state changes, you want to perform additional operations. Say you want to perform a network request. For this use case, you have to use useEffect. useEffect lets you handle side effects of your state and props in your component. You have the option to decide when your effects should run. useEffect takes two arguments: a function that needs to run on side effects, a second optional dependency array argument which you can use to control the side effects by passing in the state or prop values. From our previous example, let's say whenever the first name changes, you want to perform an API request that is going to fetch all the possible combinations of first name in your system. Using useEffect, you can do this operation by passing a function that will fetch all the possible first names in your system. And the second argument will be the dependency array that is going to hold the value of the first name. Now, whenever the user types, the value of first name will change, thus running the side effect and fetching all the possible first names from your system. So this is the ideal use case of useEffect. You might want to use useEffect to perform any API request and use the response to synchronize your component. useCallback lets you cache function definitions between re-renders. Let me elaborate that. Every time when your component re-renders, the hooks, the variables, and the functions are also recreated. From our previous example, let's say that you want to separate the input field into its own component called text input. Now this will require you to pass an onChange function to the text input component. So you define an onChange function inside your user component and pass it as a prop to the text input component. Now every time user component re-renders, a new reference to onChange is created, thus re-rendering the text input component since it is passed as a prop. Now this is an unnecessary performance problem. You can optimize this by wrapping the onChange function inside a useCallback. useCallback takes a callback function as a first argument and an optional dependency array as a second argument. Now, if you want React to recreate the function reference, you pass some values to the dependency array. Otherwise, you leave it empty so that it doesn't get recreated. Now, whenever the user component is updated, the already stored reference to the onChange function will be used. Thus, the text input component will not re-render. You can also follow the same pattern when you want to call some functions inside your useEffect. Wrap the function inside the useCallback and pass it as a dependency to your useEffect. useMemo is similar to useCallback, but instead of caching functions, you're caching some values returned by an expensive operation. From our example, let's say we get a list of possible first names from the API that we are calling inside the useEffect. Now we want to store the returned response in a state called possible first names. Now you also have a state called filter by character, which will be changed by a couple of buttons inside your component. Now, before displaying the list of possible names, you want to filter them by character. That is determined by the filter by character state. To do this, you'll create a variable inside your component, run a filter on possible first names, check each value against the filter by character state. Now, when the list of possible names is large in the amounts of thousands or millions, you don't want to run this filter operation on every re-render. This will be a huge performance bottleneck for your component. To optimize this, you can wrap the filter operation inside a use memo. Use memo takes a callback as a first argument and a dependency array as the second argument. By passing possible first names and filter by character state values to the dependency array, you tell React to run this memoization only when these two value changes. So whenever other piece of state changes, the use memo will not rerun and use the previous render's value as a result. useRef lets you store references to values or objects that you don't need for rendering. On subsequent re-renders, useRef will not change the value of the reference. useRef is most commonly used to manipulate DOM nodes. Let's say you want to clear at the input field on a click of a button. You can do this by creating a reference using useRef, pass that reference to the input field as prop. Inside the on-click handler of the button, you can clear the input field using the reference. You can also store values such as timeouts or intervals using useRef. You can also mutate the reference created by useRef. But you need to keep in mind that you cannot use useRef to display stateful information inside your component. Any mutation to the reference will not cause your component to re-render. I hope with this fundamental understanding of these hooks, you'll be able to write React components more comfortably. Let me know your thoughts in the comments, and also let me know if you want to learn more about advanced techniques of using these hooks and also other advanced hooks. Don't forget to hit that like and subscribe button. See you next time.